Hello everyone, and welcome back to another Geostats lecture video. And in this lecture video, I want to talk about how we can sort of interpret and analyze the values for this local Moran's eye, which again, this is going to be calculated for each and every polygon in the data set, and it'll give us a measure of where any sort of autocorrelation is occurring and what direction or what sort of characteristic that autocorrelation is taking on. And I want to do that by looking at the equation that we talked about in the previous video and looking at sort of three use cases or three ways that you can get something that you can interpret. Okay. And the first is going to be what happens when Zi and Zj are very close to the value of the average of the data set. So if everything is just sort of close to average, right? This term here is going to be close to this term here, and this term here is going to be close to that term there. When you do the math on that, right, when you have something minus something that is very similar in value, your result is going to come out pretty close to 0, right? If I have a value of 2 and my average is 2, right, that's going to be 0. If I have a value of 2.1 and the average is 2, right, I'll have a value of 0.1. So the closer that these things are in value to each other, the closer this I is going to be to 0. And basically what that is telling you is that if you have a value that is not particularly large, that means that there really isn't much autocorrelation happening at that location. So what I want to say is I want to sort of write this out here of saying if I sub I, right, the I value for the target polygon is not particularly large, I'm going to put here positive or negative, and we'll talk about these in just a second. Right, this indicates little to no autocorrelation. In that area. Right. Now, I guess this is a little confusing because you could argue that, well, hey, you know, all the values are the same, so that is kind of autocorrelation, but it's not showing an effect, right? You're not seeing the spikes that we would expect to see for the other two types of autocorrelation. So let's go back to this equation for a second. And let's say, okay, well, what happens when Zi is particularly high, right, is higher than this, but all of its neighbors are lower than this, okay? So let's think about that for a second. If Zi is really high and all of the neighbors that are counted are really low relative to the average, that means that this is going to be negative. So a negative times a positive means you're going to end up with a negative. So if you have a really large negative value, right, if the local I for this polygon is really largely negative, right, that means that these had very different values than these. Let me take a step back and try and explain that again. Right, if Zi is either really high or really small relative to Zi, and Zj is the opposite. So Zi is high relative to the mean, and all of the Zj's are low relative to the mean, right? This is going to end up being negative, and this is going to end up being positive, or you can flip it. But the idea here is that one of these, either Zi or Zj, is really large, and the other is really low. You're going to end up with an overall local I that is negative. So what does that mean? Right? If your I is really negative, right, that means that you have what we would call repulsion occurring. And what that means is that your target polygon has an extreme value, either extremely low or extremely high. Okay, it works in both directions. Because again, right, this is either going to be negative or positive. That target value, that target polygon, all of its neighbors have a value in the opposite extreme, right? So if zi is really low relative to the mean, then all of the zij's, or at least most of the zij's, are going to be really high relative to the mean. Or, put conversely, right, if the value at the target polygon is really high, then the values of the neighboring polygons are really low, right? So that would mean that this term would be negative. I know that's kind of a tricky concept. If it didn't make sense the first time, rewind this video about 90 seconds and just watch it again, and just think again about what happens when these are high and these are low, or when these is low and these are high. What would happen to that overall equation, and figuring out why both of those scenarios, right, would lead to a large negative local Moran's I. And let's sort of frame that again here, right? If I sub I is large in magnitude, negative in sign, right, is large negative, right, this indicates what we call repulsion in the data set. And again, repulsion means that the ith polygon has an extreme value has an extreme value relative to the mean, and its neighbors have extreme values in the opposite direction. Opposite direction, again, relative to the mean. So just to reiterate, right, if I is negative, this means we have repulsion, which means that whatever the target polygon is doing, whether it's extremely high relative to the mean or extremely low relative to the mean, right, that the neighbors are going to have the opposite, right? So if I is really low relative to the mean, then the majority of its neighbors are going to be extremely high relative to the mean. And we call that repulsion. I'm going to underline and circle repulsion in red because this, right, negative, right, if I is negative, we have repulsion. Okay, hopefully that makes sense. And again, this is probably the most tricky one to interpret. So let's go back up to the equation and let's take a look at the last case. And this would be the case where zi and zj are sort of both either really high or really low relative to the mean. And again, what I mean by that is that they're extreme in the same direction, right? So when I was negative, they were extreme in opposite directions, right? One was high relative and one was low. In this case, what if they're both high or they're both low, again, relative to the mean? Well, what's going to happen? Right? If they're both high or they're both low, right, then these numbers are going to be bigger, right, in terms of absolute value, right, because you have a smaller number or a larger number minus a constant. So both these terms are going to be either really big negative or really big positive. And because we're multiplying them together, right, if they're negative, you still get a positive, and if they're positive, well, you get a positive. So if they both follow the same trend relative to the mean, you're going to end up with a positive Moran's I, right? Because again, a negative times a negative would still be a positive. You end up with a positive local Moran's I that is large in absolute value. And what that means, as I've kind of just said, is that the zi and all of the zij's are extreme in the same direction. And that would mean clustering, right? It would mean that high values are bordered by high values, or it would mean that low values are neighbored by low values. So you see how that's different from repulsion? Right? Repulsion would mean high neighbored by low or low neighbored by high. Clustering means high neighbored by high or low neighbored by low. So let's sort of frame that up in our thing down here by saying, right, if I sub I is large and positive, right, large and positive, this indicates clustering in the data set. Right, this indicates clustering in the data set. Okay. So I'm going to do the same thing I did before, right? Positive means clustering. So to wrap this video up, what I want to do is I want to just recap again, because I think this actually explains it the best. All right, large, negative, I sub I means one of two things. It either means high bordering low, or it means low bordering high, right? And you see here that they switch, right? It's high and low or low and high. And then that compared to a large positive I meaning high bordering high or low bordering low, right? And you'd have to look at the individual polygon to figure out which one of these it is. So hopefully that makes sense. I know this was a lot, especially with repulsion. So as always, if you have any questions, please reach out. Thank you.